This is the first problem of today's Div 3, and in this problem, we're given that Vlad is planning to hold M rounds next month, and each round should contain one problem of difficulty levels A, B, C, D, E, F, and G. Now, Vlad already has a a bank of N problems, and with the ith problem, has a difficulty of AI. Now, there might not be enough problems, so we need to find how many problems do we require if there needs to be held M rounds. So this is a very simple problem. We're given that, let's say A, B, B, E, F, and you need to have two rounds. So you have two problems of A difficulty. You just have one problem of B difficulty. So you need one B problem. You need one C problem. You need one D problem. You need one E problem. You need one F problem. And you need two G problems. So two, 4, 2, 6, and 1, 7. So total 7 problems. Now there are many ways to solve this. The easiest way is just count how many of these A, how many of B, how many of C, how many of D, and how many of E and F you have. And finally, you need M, so decrease that count from these count I. And make sure that you're taking maximum of this or 0, because it's possible that you might have 3A problems, but this doesn't mean that you need to do a -1 for this. Like the contribution of this is not -1, but 0. You need 0 new problems of type A. So let me show you the implementation. So this is the implementation. In this, I have taken N and M as input. I have taken the string S as input. This is my count. I have created a count vector initially, like why 7? Because there are 7 problems, and each should have a count of M. Then I'm iterating through my string S. I'm decreasing the count respective to this problem with 1, and I'm always taking the maximum of 0 on this. Finally, I can print the sum of counts, which is the remaining counts of problems I want. Is it clear? Okay, so let's go to the next problem. So in the next problem, we are given that Dimitri has n cubes numbered from left to right, from 1 to n. The cube with index f is his favorite. Dimitri threw all the cubes on the table. The ith cube showed value ai, which is between 1 and 100. And after that, he arranged the cubes in non-increasing order of their values from largest to smallest. If two cubes show the same value, they can go in any order. After sorting, Dimitri removed the first k cubes. Now he's interested at whether or not he removed his favorite cube. So this is again a very simple problem. So what we are given that there are n cubes, and each cube is thrown, and there is a AI value. Like for each cube, a AI value is associated with it, and then they are sorted in non-decreasing order, I think, or what is it? They are sorted in non-increasing order. So this means in, like, either the values will decrease or they'll remain same. After that, the first k cubes are removed, and Dimitri wants to know whether or not he has removed his cube or not, his favorite cube or not. So first of all, just find what is the value, what is the value of the favorite cube. So we can find like uh, F block is the favorite, right? So if indexes are starting from 0, we can find like this: what is the favorite block's value after the cubes are rolled. Then we can sort the cubes in non-decreasing order, And once we have sorted in non-decreasing order, just check that if k is equals to n, or a of k is less than, like, if k is less than n, what does this mean? If k is equals to n, it means that all cubes are removed, right? And if a of k, a of k is less than favorite, A of k, like what whichever was the kth cube which is removed is less than favorite. This means that favorite would be ahead of A of k, and these are sorted in non-decreasing order. So that's why this is also removed. Otherwise, if A of k is equals to favorite or A of k minus 1 is equals to favorite, you can figure out then it might would have been removed or it might not would have been removed. If A of k is equals to favorite or A of k minus 1 is equals to favorite. Why? Because in those cases, you removed up till here. If this kth cube was placed here, then it would be removed. If it is placed here, it won't be removed. Right? And otherwise, lastly, if these cases are not there, then simply it is not removed. Somebody asked, what is non-increasing? So non-increasing is that your array is not increasing. So something like 10, 10, 3, 3, 2, 1 is non-increasing. 10, 11, 3, 3, 2, 1 is not non-increasing because it increased here. After this point, it decreased or it remains same. So if your array is either decreasing or it is remaining same, then you would say that it is non-increasing. Is it clear? A of k minus 1. See, if your two values are same, 10, 10, 30, and you are removing till second point, and this is your favorite. So in this case, maybe it would be removed or maybe it won't be removed. How can you say? Like we have already checked that A of k is, like we have removed this case. If A of k was less than favorite, then we would have definitely removed it, right? And we have already checked that k is not equals to n, because if k is equals to n, then also we have already removed. So then you can simply check that, like if A of k is equals to favorite, then this would mean, and A, what else? If A of k is equals to favorite and A of k minus 1, that is A of, so removing A of k plus 1, and this is, like if I write indices wise, so this is k and this is k minus 1. This is it making sense? If I'm starting my indices from 0, then like not like, maybe you got confused with this. So if both of these are equals to k, then you might remove this because this is your favorite. Let's say this is your favorite. Then your favorite can come here also and here also. If it is here, it may be removed. If it is here, it may not be removed. So maybe. Is it clear now? Yes, there is a maybe case also. F is favorite index. Yes, F is favorite index, but this is your favorite, like f f is initially, in the initially, it's not the favorite index, it's the favorite cube. Once you once you rolled it, you get this much value, and there are other cubes also which got the same value. Is it making sense? So now you remove the first k. So if k minus 1 and k, both of these are having the same value, then you may remove it and may not remove it. Is it clear? Okay, so let me show you the implementation. So this is the implementation. First, we have taken n, f, and k as input. Then we have taken like all the values of these cubes after rolling them. This is the number of, like the value for the cube which was favorite, this fth cube. Why f minus 1? Because indices are starting from 0. This we have sorted in non-increasing order. So after sorting in non-increasing order, I'm checking first this thing. If k is equals to n, all the cubes are removed. If a of k is less than favorite, then also this favorite cube is removed. Otherwise, if a of k is equals to favorite, a of k minus 1 is also equals to favorite. Both of these values are same, then it may be removed or may not be removed. Then simply, otherwise, if these two conditions are not true, then you are not removing. Simply print no. Is it clear? Yes, no. Okay. So let's go to the next. Next problem is this. In this problem, we are given that Sophia had an array of n integers a1 to an. One day she got bored with it, so she decided to sequentially apply m modification operations to it. Each modification operation is described as a pair of numbers cj, dj, and means that the elements of the array from index cj should be assigned to the value dj. That is, perform the assignment a of cj is equals to dj. After applying all the modifications operation sequentially, Sophia discarded the resulting array. Now we are given an original array and a new array, and we are given the values of d. We are not given the values of c. Like in operation, we have cj, dj, right? But we are only given these d values, not c. And we are given the original array and new array, and we need to find whether it's possible to get the new array from the original array. So let me explain. This is also a very simple problem. So we have cj, dj kinds of operation. These are m number of m operations. And for each operation, we have to do this thing. So after this, we're given the original array and a new array. So originally, let's say this is the array, and finally you want this array. So if these two values are same, you don't have to do anything. If these two values are different, if this is 3, this is 10, you need a 10 here. Is it making sense? You need a 10 here, no matter what. Yes, no. So if you need a 10 here, you must have a 10 here in DJ. You are not given CJ. You can choose any CJ. So you'll choose this as your CJ, this index. You need a 10. If you need a 7 here and you had a 5, you need a 7 here. So just check what all values you need. You need 7 here, you need 7 here, you need 3 here, and you need 10 here. And this is same. So just check whether or not you have 3 once, 7 twice, 10 twice in DJ. If you have these, you're good to go. Why? Because let's say even if you're getting 10 twice, if you're getting 10 twice, you'll keep it once here and again here. Or even if you're getting it 100 times, you'll always keep it here only. So you just need it twice. But if you are getting it less than twice, then you cannot do this. There is one last thing that you have to do. Let's say DJ is of this type, like DJ arrays 10, 7, 7, 3, 10, 11. So 10 you can put anywhere, 7 you can do, 7 you can do. Let's say before this you had a 5 also. So 5 you can place here in place of 10 because eventually you will replace it with 10. But the last value, which whatever is the last value, if that value is not included in the new array, then you cannot create your answer. Why? Because 11 cannot come anywhere. 11 is nowhere and you have to have 11 somewhere. If this value is something which is not actually required by replace, but is actually present in the new array, then all the values that are not required before it, let's say there was a 1 here, you can keep it here. Because at the last, you'll just keep the 5 here. So last value should always come in new array. And for the rest, you just need to count that the number of places that require this change is more than, like the count of those numbers is more than the count available in DJ. Is it making sense? Yes, order of this matter. Like I think, is it clear now? Like why does the order matter? Because the last number cannot be, like if it's not coming in new array, it cannot be placed anywhere. Okay. Like, what do you want me to repeat? Can anyone just unmute? Like, let's have a conversation, but then it would be easier. Like, explain it again, what part?
Uh,
Yes, yes.
Actually, I have one more approach.
No, no.
Can
If you
can I
have the
discuss?
doubt, like first, let's clear the doubts. Then we
Okay.
can. So, is anyone having any doubt regarding the solution?
I think what we are asking is for the order. Like, how does the can you explain the order of
Okay,
the
so
digits?
how
How
does the
does
order
that matter?
matter? See, your final array is something like 10, 3, 5, 5, 1, 6. and your operations are like something like 10, 3, 1, 2, 3, 5, 7, 5, 1, 7. So tell me 10 can be kept here, okay, because originally you had some x, y, z, x, y, z. So 10 you can keep here and you'll get 10 in its correct place. 3 can be also done. 1 you can keep here. 2 you don't have any, but let's say you keep it here. 3 again you'll keep here. 5 you'll keep here. So even though there was a 2 here which was not required, but eventually it is overwritten by 5. But the last thing, which is 7, 7 is not needed. Where will you keep it? It is required because by rule you have to do A of Cj is equals to Dj. So Dj is decided, it is 7. What will you do? What is Cj? What is the index? So no index is there in new array which requires to be 7. So that's why in this case the answer is not possible. If this was something that was in the new array, that is 5, then the answer would have been possible. If the counts were more.
सर ये समझ नहीं आया सर ये।
हाँ, इसको मैं एक बार फिर से बताता हूँ। देखो, अगर तुम्हारे पास कुछ भी एक नंबर है यहाँ पे कोई भी तुम्हारे पास x नंबर है, वो x अगर न्यू एरे में नहीं आ रहा है तो इवेंचुअली तो तुम सिक्वेंशली कर रहे हो ये ऑपरेशंस। सो आखिरी ऑपरेशन तुम इसके साथ करोगे। अब तुम्हें एक इंडेक्स डिसाइड करना है जिसको तुम x दोगे, पर तुम्हारे न्यू एरे में तो कोई x तो है ही नहीं, तो तुम किस इंडेक्स को दोगे? x नहीं दे सकते, राइट?
यस सर।
हाँ, अब मान लो कि यहाँ पे कुछ y एलिमेंट था, y एक जगह पे है ऑलरेडी, y यहाँ पे है, तो इससे पहले कि जितनी भी ऐसे एलिमेंट्स हैं जो तुम्हें एरे में नहीं चाहिए, वो तुम सब इसी को दोगे, इस पोजीशन को बार बार ओवरराइट करते रहोगे एंड इवेंचुअली तुम इसको y से ओवरराइट कर दोगे। तो अगर लास्ट एलिमेंट एरे में प्रेजेंट है न्यू एरे में, सो इट्स ओके। अगर नहीं है, सो द आंसर इज नॉट पॉसिबल। इज इट
यस
क्लियर
सर,
ना?
समझ आ गया सर।
Anyone having still this doubt? Okay, perfect.
Hello,
Yes,
sir.
yes.
I come up with the exact approach, but I was not able to implement it. So can you suggest something that how can I improve this?
Like implementation, like it comes with only like problem solving. If you are able to come up with the approach but you're not able to implement it, you need to solve problems regarding implementation. Like this is not any like this has nothing to do with any algorithm or any problem solving logic skills. Like this is the basic problem. Or like it's quite possible that you misread the problem, like you were like completely going in the wrong direction. So let me show you the implementation. So this is the implementation. I have first taken array A as input, then I have taken array B as input. Then I have taken D, like the operations D values as input. I have created two maps. Count one is how many times I need some values to be replaced in new arrays is having some values which are not in array A at those places. So I'm counting for all those places how many values I require such, because those have to be in B. Those have to be in D, not in B, but in D, because those operations. So I'm counting each value, how many times each value occurs in D also. Finally, this is my check. I'm checking that each value, like count one of xy, count one of x is basically how many times I require some value, which is in B and like which is in my new array and not an original. So I'm just checking that it count 2 of x. If this thing count 2 of x is nothing but how many times this value occurs in array D. If this value occurs less number of times in array D, then it occurred in array B at places in which original array didn't have this value. Then I'm marking my check. This is basically my check whether my answer is possible or not. I'm marking it as false. Finally, I'm also checking one more thing, that my last element, whatever is my last element, needs to be in my array B, that is new array. So count of last element, if the count of last element in array B is 0, my answer is also not possible. Finally, I can print yes or no. So this is the implementation.
सर मेरा एक डाउट था सर, जो
Yes,
लास्ट एलिमेंट है उसकी पोजीशन लास्ट होना नेसेसिटी नहीं है?
last जो element है उसकी
उसका जो इंडेक्स होना चाहिए वो लास्ट होना चाहिए ना, वो भी चेक करना चाहिए कि वो लास्ट इंडेक्स पे अगर करे।
नहीं लास्ट पे क्यों करे मैं?
क्योंकि
हम
सर
चेक कर
सीक्वेंस ही
सकते
चल
हैं,
रहे हैं, तो
कहीं
ओवरराइट
पे भी
करने के
रखूँ मैं।
बाद लास्ट इंडेक्स मैच करना चाहिए ना,
नहीं
लास्ट
नहीं,
वैल्यू।
कहीं पे भी रखूँ मैं, मतलब लास्ट एलिमेंट मेरे पास ये ओरिजिनल एरे है, ये न्यू एरे है, और मेरे पास एरे डी के ऑपरेशन में मेरे पास लास्ट में 7 आ रहा है, तो इससे क्या फर्क पड़ता है 7 अगर यहाँ पे भी है? मैं इसको असाइन कर दूंगा। मतलब मेरे को तो बस ए ऑफ सी जे इज इक्वल्स टू डी जे करना है ना। तो
ठीक है सर।
सी जे डिसाइडेड नहीं है, सी जे तो कुछ भी हो सकता है। मुझे, ये कौन है नोट किया?
सॉरी सर। वो
तो वो, एक सेकंड मैं नोट बंद कर देता हूँ। तो मेरे पास ये जिसने भी किया उसे हटा दो, मैं नहीं हटा पाऊंगा शायद उसे। ये मेरे को बस ये ऑपरेशंस गिवन है, ए ऑफ सी जे इज इक्वल्स टू डी जे। तो मुझे ये ऑपरेशंस सिक्वेंशली करने हैं, मतलब सी जे डी जे कुछ ऐसा रहा होगा कि इंडेक्स 3 पे इंडेक्स मतलब 5 वैल्यू प्लेस करनी है, इंडेक्स 5 पे 7 प्लेस करना है, इंडेक्स 1 पे 6 प्लेस करना है, ये सिक्वेंशली ऑपरेशंस करने थे। अब मुझे ये नहीं गिवन है, ये मैं कुछ भी चूज कर सकता हूँ। मुझे बस ये प्लेस करना है कि पहले 5 कहीं पे भी रखना है, फिर 7 कहीं पे भी रखना है, फिर 6 कहीं पे भी रखना है। तो लास्ट वैल्यू लास्ट पे नहीं आना चाहिए, बस कहीं पे भी आना चाहिए। इज
ठीक
इट
है
ओके?
सर, थैंक यू, हाँ समझ गया।
सर, सर इम्प्लीमेंटेशन एक बार और बता सकते हैं, क्योंकि इम्प्लीमेंटेशन करते नहीं बन रहा था। एल्गोरिथम तो कुछ सेम आ रही थी।
बता देता हूँ। तो इम्प्लीमेंटेशन में क्या किया है देखो, सबसे पहले तो मुझे दो चीजें चेक करनी थी। पहली चीज ये है कि मेरी जितनी भी जगहों पे, कुछ कुछ जगह पे तो वैल्यू सेम आ गई, उन्हें मुझे छेड़ने की जरूरत नहीं है। कुछ कुछ जगहों पे वैल्यू सेम नहीं आई है, यहाँ पे 3 है मुझे 7 चाहिए, यहाँ पे 5 है पर मुझे 7 चाहिए, यहाँ पे 4 है और मुझे 2 चाहिए। तो मैं ऐसी जगहों पे काउंट कर लेता हूँ कि मुझे ऐसी जगहों पे 7 कितनी बार चाहिए, 2 कितनी बार चाहिए, मतलब बाकी जगहों पे भी कितने एलिमेंट्स कितनी बार चाहिए। अब मुझे ये चेक करना पड़ेगा कि 7 मुझे 2 बार चाहिए, तो 2 बार 7 मेरा 2 बार डी में भी होना चाहिए। अगर डी में एक ही बार है तो आंसर पॉसिबल नहीं है। 2 मुझे एक बार चाहिए, मुझे 2 वन बार चाहिए, क्यों? क्योंकि ताकि मैं इधर इस पे इसको ओवरराइड कर पाऊँ। अब अगर 2 मेरा एक बार भी डी में नहीं है तो मेरा आंसर पॉसिबल नहीं है। तो सबसे पहले हम काउंट करेंगे हाउ मेनी टाइम्स दीज आर दी लाइक इन दीज प्लेसेस, हाउ मेनी टाइम्स ईच दीज वैल्यूज आर अकरिंग। 7 2 बार आ रहा है, 2 एक बार आ रहा है, और फिर मैं इन वैल्यूज को चेक करूंगा डी में, कि डी में जो काउंट है 7 का काउंट है, इट शुड बी मोर देन द काउंट ऑफ दीज वैल्यूज, लाइक यहाँ मुझे जो चाहिए। तो वही सेम चीज,
या इन कटेंगे।
यहाँ पे करी है। इफ ए आई इज नॉट इक्वल टू बी आई, तो मेरे को बी आई वैल्यू चाहिए होगी। तो मैंने काउंट 1 में इंक्रीज कर दिया बी आई का। ये मैंने केवल काउंट कैलकुलेट किया है एरे डी में जो वैल्यूज आ रही हैं। ये मेरा चेक है, अगर ये 1 होगा तो आंसर पॉसिबल है, वरना अगर 0 है तो आंसर पॉसिबल नहीं है। मैं आइटरेट कर रहा हूँ काउंट 1 में। काउंट 1 में ये पेयर है, एक्स इज अकरिंग वाई टाइम्स। तो मैं कर रहा हूँ एक्स इज अकरिंग वाई टाइम्स, तो एक्स जो है, मतलब ये काउंट 1 क्या था, ये था कि मेरे को जो मेरी जो डिस्क्रिपेंसीज आ रही हैं वो मुझे कितनी बार, मतलब एरे न्यू एरे में कितनी बार चाहिए बी आई। तो मुझे एक्स वाई टाइम्स चाहिए, तो ये एक्स डी में कितनी बार मिल रहा है। अगर ये एक्स जो है डी में इस y से कम नंबर ऑफ टाइम्स मिल रहा है तो मेरा आंसर पॉसिबल नहीं है। और फाइनली मेरी जो लास्ट वैल्यू है डी में, वो अगर एरे बी में जो कि न्यू एरे है उसमें नहीं मिल रहा है तो आंसर पॉसिबल नहीं है। सो आई कैन प्रिंट अकॉर्डिंग टू एफ यस और नो। इज इट क्लियर?
ये लास्ट वाला समझा सकते हैं, लास्ट जैसे काउंट बी बिगिन बी एंड ये।
ये वाला,
यस
ये वाला
यस।
ना, इसमें काउंट बेसिकली एस टी एल फंक्शन है ये सी प्लस प्लस में। तो ये क्या करता है कि मतलब ये वाला एलिमेंट मेरे एरे बी में कितनी बार आ रहा है। अगर एक बार भी आ रहा है तो मेरे को मतलब चल जाएगा, मतलब बस ये आना चाहिए एरे बी में कहीं भी, लास्ट वाला जैसे हमने भी डिस्कस किया। अगर नहीं आ रहा है मतलब इसका काउंट 0 है एरे बी में, तो मेरा आंसर पॉसिबल नहीं है।
ओके ओके, थैंक यू।
इज इट क्लियर?
यस।
एनी अदर डाउट्स?
नो थैंक यू।
ओके, so let's go to the next problem. So in this problem, we're given that GCD greatest common divisor of two integers x and y is the maximum integer z by which both x and y are divisible. For example, GCD of 36 and 48 is 12. So this, we all know what is a GCD. Now Christina has an array A consisting of exactly n positive integers. She wants to count the GCD of each neighboring pair of numbers to get a new array B called GCD sequence. Now, like after getting this array B, she wants to determine whether it's possible to remove exactly one number from the array A so that GCD sequence B is non-decreasing. So non-decreasing we have earlier discussed in, I think, second problem. What is non-increasing? So exactly same thing is non-decreasing, like reverse of it. So the value shouldn't decrease. I think there also I think there was non-increasing, here it is non-decreasing. So let me explain this problem first. Initially, there is an array given A. We'll create a new array B, GCD of these two, GCD of these two, GCD of these two, GCD of these two, GCD of these two. This is the new array B. After this, we want that for every value Bi should be less than equals to Bi plus 1. This is non-decreasing. The value should either remain same or increase, but it shouldn't decrease. Is this thing clear up till now? Now, we are required to remove exactly one value. Like it's not optional. It's not like we can remove at max one value. It's not at max. We have to remove one value, and after that we need to find whether this thing is possible or not. So let's say we don't remove any value. Can we find array B? Can everyone find array B? Yes, no? Okay. Now let's say without removing any value, you find that this thing satisfies that array B is already non-decreasing. In that case, your answer is yes. Why? Because you can simply remove this last value in array A and your array B will also get decreased by 1. And since this condition was earlier being followed, even if you remove this, the condition is still followed. So answer is yes. In case you find that your array A is always like after finding your array B without removing any element, your answer is being satisfied. Or you can also remove the first element. Yes. Is this thing clear up till now? Now we have to remove one element. Now, if we have to remove one element, that means, first of all, we find array B and we find that, okay, is this condition being satisfied or not? If this condition was being satisfied, we have our answer. Now, the second case that the condition is not satisfied. So in array B, we have something like increasing, maybe decreasing. So we just find the first place at which the value decreases. And we have like, what was our array A? We had our array A like this, right? Like this. GCD of these two was this, 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 GCD of these two was this. So we found that for the first time, like this place and this place are not like following the rule that B should be non-decreasing because of this place. So now what we'll do, either like these two places. So these two places GCD depends on this place, and this place, right? Yes, no? Like these two places GCD, if you change this value, would these two GCDs change? No. If you change this value or any value before this, would these two GCDs change? No. If you change anything after this point, would the GCDs change? No. So you have to change one of these three. 1, 2, and 3. These three. So just once remove this value, check whether your array B, the new array B that you get, is non-decreasing. If it is, your answer is yes. Then if it is not, remove this second value. Remove this second value, again calculate array B and check if your array is non-decreasing. If it is, your answer is yes. Again, if it is not, remove this third value, again calculate your array B, check whether you have your array B is non-decreasing. If it is, your answer is yes. Otherwise, your answer is strictly no. Because after removing this also, and this also, your GCD, your array B is not qualifying. If it is not qualifying, whatever you do on this side or you do on this side, these two will always be the same. So this thing will always be there, that this value is more than this value. So your array B will never be non-decreasing. Is it clear? Simply. Yeah, this is kind of like, is anyone having any doubt? Why the third value? Because the GCD of this also depends on this. There can be some case in which 3 can be removed. Also, like I won't be sure, like if your solution is passed without checking like all of these 3, it might get hacked. Because this is a div3 and there is like open hacking phase going on. So it's possible, like right now, the solution is not checked for all the test cases. Why, like, you can unmute yourself and ask me. Like, I'm not able to, why 1, 2, and 3? What do you mean by 1, 2, and 3? Like, you have to remove one, like, you have try to remove one. If your answer is being, like, if your new array B is being satisfied, it's okay. Otherwise, try remove this second element. Otherwise, remove this third element, one by one. Is it clear? If you have just checked these two and your answer is like you got accepted, it's possible that your mate solution might get hacked, because clearly I can come up with a test case. Like I haven't really thought of any other approaches. But surely there would be other approaches. This is just the first thing that came to my mind. Okay, so I'll show you the implementation. So in this, I have first taken the number of test cases as input, then I've taken the size of array A. I'm taking array A as input. I'm calculating array B simply as BI is GCD of AI and AI plus 1. X is nothing but the first place at which this condition breaks. That is, array B is now no more non-decreasing. BI is more than BI plus 1. So it is decreasing at this point. So I initialized my X with I and I break this loop. If my X is -1, this simply means that my array is non-decreasing. Array B is non-decreasing. So I don't have to do anything. I'll print yes. Otherwise, I'm checking at X plus 1 and X plus 2. This is simply same as that, 1, 2, and 3. 3 places I have to check. If at any of these 3 places, what I'm doing, I'm just removing, if I is equals to X, I'm removing it. Otherwise, I'm creating a new array C out of A. Very simple. This is just like long way of writing this, but just remove X from array A, calculate your GCDs, check they are non-decreasing. Your last GCD is always more than equals to Y. Like if it is last GCD is more than Y, then it's not non-decreasing, so return false. Otherwise, if it is always like in non-decreasing fashion, so return true. So check for X plus 1 and X plus 2. If any of these satisfies, print yes, otherwise no. Is it clear?
I have a question.
Yes, yes.
Like in the for loop, in the first for loop, we have like start from I from 1 to n minus 1.
Yes.
What does that signify? You're removing the first
My
element
indices
and the
are
last.
starting from 1. If your indices are starting from 0, you should start from 0.
Okay. So you have used one based index, right?
Yes.
Okay.
Why I have
That's
used
okay.
one based indexing? Because I have declared my loops out, my arrays outside. Why I have declared my arrays outside? Because I wanted to use the same arrays here without passing them. So
Okay,
if
okay,
I have to declare them outside, I have given this much size. So since the size is far more than required, I can start from 1.
okay, got it.
Any other doubt? So let's go to the next problem. So the next problem is this. In this problem, we are given that we are given a matrix A of size n cross m containing a permutation of integers from 1 to n into m. And a permutation is simply like it's an arrangement of
Once,
numbers.
can you just repeat how did you implement that check function?
How did I implement?
That check function, like how
Check
you are
function.
checking.
Like, yes, yes,
Yeah.
yes. I'll show you. So check function is nothing but I have to ignore the element at x. I'm removing the xth element from array A. So just create a new array C. I'm iterating through this. This is the long way of doing it. You can do it like shorter also, but just create a new array C. If you are at xth index, just continue. Otherwise, create in like keep all the elements, keep adding all the elements to C and just do the same thing. This thing. From C, create a new array B and check this thing. Instead of doing this in 2 loops, what I've done, I've just said that, okay, my last GCD is something, and I'm calculating my current GCD as Y. If Y is less than my last GCD, I'm returning false. That is, it is now no more non-decreasing. My array has decreased. My GCD value has decreased. Otherwise, I keep on doing this. Finally, I can return true. Is it clear? Okay. Clear, right? Okay. So let's go to the next. So in this problem, we were given a matrix of size n cross n containing a permutation of size, so like permutation of numbers from 1 to nm. Now a permutation is nothing but all the numbers from 1 to n. A permutation of size n is nothing but all the numbers from 1 to n appear exactly once in random order. So now we are given 2 matrices, and in one operation, you can choose any columns C and D, swap these, or any rows C and D and swap these. Finally, we need to find whether we can convert our original matrix A to this matrix B. So now if we closely look at this problem, like I think everybody would have been able to understand what the problem is asking. But from there, the problem seems to be difficult. Like, see, we're given a matrix, and this matrix is filled with a permutation of numbers from 1 to n into m. And in one operation, we can choose any 2 rows and we can swap them, or any 2 columns and swap them. So tell me one thing, in a row, if there are 2 elements, in the final also, these 2 elements will be in the same row. Maybe they are here and here. Like they will be in the same row. Yes, no. Like their columns might change, they might be closer to each other, but they will be in the same row. They can never go in different rows. Similarly, if there are 2 numbers in some same column, eventually they will also be in same column. Yes, no. You cannot do something like some operations resulting in that 2 numbers which were earlier in same row are now in different rows. Is it making sense? Because we are just swapping rows and we are swapping columns. If this part is clear, we'll move to further, and like pretty much here the problem is solved. So think what you can do. See, in original array, you can see each element would be occurring exactly once. Every element is exactly occurring once because it is a permutation of 1 to n into m. So you can count for every element what is the row at which it is occurring and what is the column at which it is occurring. Yes, no. So for every element, you know what is the row at which it is occurring and what is the column at which it is occurring. Now, once you get the new array, you just need to count that if your current element, let's say,
You can do something like this, right? Like you can take one column in A and all those elements of column A has to be in one column in column B. So you can check
yes, you
some.
can do it like that also. But like after this point, it's just about implementation. The implementation that way, it can be little tedious that you are checking that all of these elements are in same column, all of these elements are in same column, right?
Yeah.
You can do it like that. It can be a little tedious. You might have to do it for rows also. But a better way is just for original matrix, just count, like just calculate what is the row. This is my, I'm taking my, like this is my first one, A11, A12 for all the elements. Just find what is the row and what is the column. This is the elements. Like for each element, I'll have what is the row and what is the column. Okay. Then for the new, just do one thing. That if your current element row, like in this is your element now. This is your ith row, jth column. If I is not equals to the row of this element, like this much, this thing, the row of element from original array, that means you need to swap this row somehow, right? You cannot do this with column operations. You have to do with this row operations only, right? Yes, no. If your I is not equals to R of this element, that is original matrix row, you have to swap this. So just create a map. And for this, let's say this is my count of rows. So for this, I'll increment what? Now I need two things. The place from which I'm swapping this, the place from which I'm swapping this. So what is the place from which I'm swapping this? I. And to where I'm swapping this? R of row. So I can write, just maintain this thing. So from this is the place to which I'll swap. And here from here I'm swapping this. And same thing, if your j is not equals to, if your j is not equals to column of this element, you will say that my count of this column is equals to column, like whatever the column is required to where you will swap this and j. Now tell me, how can this be of help? Basically, these should also be equals to, like how much this should be, how much this operation should be. How many number of rows, how many number of elements do you have in a row? How many number of elements do you have in a row? M.
M elements.
So can you swap just one element? No, right? So there should be exactly M elements going from this place to this place. This should be, for every of these operations, the count should be equals to M. And how many elements do you have in one row, one column? Each column has N elements, right? So this, for every count, for every operation of these type, like every element going from here to here should, for the total number of operations like this should be N. For every column operation, elements going from here to here should be N. Not more than N, not less than N. If there are such kind of operation, it should be exactly N. Is it making sense?
But one doubt I have here, like it may go to an infinite loop, right, by using this approach because you're always checking if they're not equal. So every time you swap
No, no,
things.
no. You're just iterating through the two matrices. From the first matrix, you calculate these two. From the second matrix, when you are iterating, you just check if this is not this, you'll increment this, that you have to do one operation. If j is not equal to this, you'll increment this. Finally, you can check that count of all of these operations should be equals to m. Count of these operations should be n. Why? Because if this is not, this means that if you're swapping two rows, your m elements will go from one row to another.
So what you're doing here first, basically, like you're first you did this, and second, when you're iterating, you'll check for first index. If it is not
Yes,
equal,
yes. I'm taking, yes.
you'll take the entire row and put in another row. You'll swap both rows basically, right?
Like
If
I'm
I
not
are
actually
not equal.
swapping, but I'm assuming that if I swap, there will be n elements going from one place to another, not just one element. Because of this one swap, n elements will go. I'm not actually
Okay.
swapping. So that's why, see, I'll give you the code. I'll give all the codes. You'll get all the codes. Don't worry. So
Yeah, but even if you swap, I think it will work. It will work, right? Like if after all the swaps, both has to become equal. So something like that.
yes, but don't actually swap. If you start swapping, your time limit might exceed. But yes, if you had the enough time complex enough time limit, if you started swapping, eventually both should become same. So what I have done, first I'm taking n and m as input, then I'm calculating this eighth element in original array is occurring at ith row and jth column. Then I'm iterating through my second array, second matrix, and if my eighth element is currently at ith row in second matrix, but RA, that is in original, it was not at ith, so I have to do one of these operations. So I'm incrementing this, that one of my element will go from ith row to RA, whatever this row is. And if my column is not same, then one of my elements will go from this column to this column. Eventually, I need to check these two things, that these operations, like elements going from one column to another column and one row to another row, should be like elements in column are n and elements in row are m. So just check that row, when you are swapping two rows, you are checking that the number of elements going from one row to another row is m, and elements going from one column to another column is n. Finally, you can print yes or no. Simple. If your element is going, if your any element is going from one first row to third row, there should be m elements going from first row to third row. Why? Because each row has m elements. If there are just, you need there are 5 elements in a row and you just need 3 elements from first row to third row, it is not possible.
That count is a 2D array, right?
Yes.
So like that
Count
count.
is not 2D array. Count is just like how many numbers are going from this row to this row and how many numbers are going from this column to this column. Count
How
is
many numbers are going from this row to this row?
yes, ith row to rth row and jth column to cath column.
Okay.
This is a map, not a matrix. This is not required. Okay, let's go to the next problem. I'll share all the codes, don't worry. So this is the last problem, like the last problem which I'll discuss. And in this problem, we are given that Alice and Bob are dividing the field. The field is a rectangle of size n cross m. Rows are numbered from 1 to n, from top to bottom, and the columns are numbered from 1 to m, from left to right. So the cells intersection, or like our intersection of row R and column C, denoted as R comma C. Now, Bob has K is between 2 and 10 to 10 to the power 5 fountains. All of them are located in different cells of the fields. Alice is responsible for dividing the field, but she must meet several conditions. To divide the field, Alice will start her path in any free without a fountain cell on the left or top left of the field and will move each time to either an adjacent cell down or right, and her path will end on the right or bottom side of this field. Now, Li's path will divide the field into two parts. One will belong to Li's, and this path includes this part includes the cells of the path. The other is of Bob. Now, Alice will own the part that includes the cell last row, first column, and Bob will include the cell which is first row, last column. Now Alice wants to divide the field in such a way that so that she gets as many cells as possible. And Bob wants to keep ownership of all the fountains, but can give exactly one of them to Alice. So first need to find the maximum number of plot size Alice can get if Bob does not give her any fountain. And then we need to print k integers. AI is 0 if Bob gives Alice the ith fountain and the maximum possible size of Alice's plot doesn't change. AI is 1 if Bob gives Alice the ith fountain and the maximum plot size changes. So first of all, let's explain what this problem is. So Alice is going to start anywhere, like from any of these cells. And some of these have fountains. Now, if Alice's follow this path, Alice follows this path. So Alice will get precisely all the cells here. This is Alice's. So this is the size. Now this is just one way. Alice, first we are checking that Alice should never, like Alice is not taking any cell with the fountain. Then we'll see what to do with the fountains. But if Alice has not, like, it doesn't have to take any fountain, then what is the maximum number of cells, maximum plot size? So how to do this? Any idea? If Alice cannot take any fountain. Very simple. Alice will keep on going in this direction until she knows that if there is a fountain here, then she'll go down and just below. Like for every column, like if this much you're able to understand, you're able to get the remaining part. See, let's try to find the maximum plot size Alice can get without taking any fountain. So let's say these are the fountains. So Alice will start from here. Like for every column, Alice will go just to the next cell, which is right after the last fountain. So for this, it is this cell. Let me cover this with another color. So this cell, this cell, this cell. Now you cannot go up. You can go either down or right. So this cell and then this cell. So these blue marked cells are the cells which are right, like just down the fountain, last fountain in their respective columns, or same as the previous one, like this is same. So Alice will follow this path. And we can see that this will give her the maximum plot size. Is it making sense? Yes, no? Yes, no, anything? So is this thing clear? Like we'll move to the next part then. Okay. So now calculating this has like it's one thing, like how to calculate this. Like calculating is also easy. Just check for every column where is the last fountain row wise occurring, and accordingly add the remaining rows to your plot size. Now, how to do, like how, let's say this fountain is removed, then your allies can go like this. So then like the plot size is increasing. But let's say this fountain was removed, like allies can have this fountain, then the plot size will still remain same. So how to calculate this? Like when is the plot size increasing and when it is not? So from this depiction, it is clear. See, once you have the maximum size, you just need to check that your What? Your row, if your maximum row is more than whatever it was previous, then giving this fountain to Bob, like, see, like, giving this fountain to Bob will increase, like, giving this fountain to Elise will increase his plot size, but giving this fountain to Elise won't. Why? Because before this column, all the lowest fountains were before it, and before this column there is a fountain which is after it. So you just have to check if you are, if this is the ith, if this is the ith, your ith column, and for checking, just check if your, this is your ith fountain and this is the cth column. So just check before all of these columns, if there is no other column which has a fountain after this point, after, like, beyond this or below this, then yes, the plot size would increase, otherwise no. So, like, it would be much more clear, like, if I show you the implementation. So see, first, taking n, m, and k as input, this is my map and this is my another map. So why two maps? See, first map is for that there's a fountain x, y at ith, like ith fountain is at x comma y. So this is for the this map. This is the purpose of this map. So ith fountain is at x comma y, and yth column is having a fountain which is at low, like, what is the maximum row at which I have a fountain in yth column? It is m1 of y. And overall, I can add x, that is the lowest fountain among all rows is at u. Then this is how we calculate the initial maximum, which is O. How is it being calculated? Just iterate through your M1, like, your columns, and M1 is having the fountains row which are, like, at the lowest, or which are having the maximum row value. So if your current row is more than the previous rows, then just include this much. Otherwise, if your current row is more than, like, less than your previous rows, then the same thing will be getting continued. So just multiply these number of rows, n minus r, whatever row, like whatever row is left, r is 5, total number of rows was whatever, like, let's say 7. So 7 minus 5, these rows will be getting covered, and m plus 1 minus e. What is e? E is your column up till which your fountains were there. After a point, there are no fountains. So that's why this is just adding C. Let me explain this. This complete column is not having any fountain. So whatever your fountain value was up till here, you need to add the same thing here. So this is what I have done here. After this point, once you have the maximum plot size without taking any fountains, you can go through the, again, column wise, you can go, and now you would require this m2, like the fountain which is at x comma y is at ith number. So for the ith, you can check if that is till now the fountain which is at the lowest point, then mark it as 1. Otherwise, just keep it as 0. Finally, we can print our answer. And why do we need m2? M2 is basically x comma y fountain is occurring at ith index. So your answer should follow that order only. So that's why m2, this map was needed, m2. So the implementation is complex, but the idea is relatively simple. Any doubts? Okay, so that's it. Thanks for joining. Bye bye.